Hello viewers, in this lesson we will be discussing about another important aspect of probability distribution, which involve mathematical expectation, which is mathematical expectation. So you can be asked to calculate the expected value of a random variable, and the random variable can either be discrete random variable or continuous random variable. And you know, if it is a discrete random variable, then we're talking about what probability function, and if it is a continuous random variable, we're talking about what probability density function PDA. That should tell you that the aspect of mathematical expectation is divided into two, which is the probability function and for probability density function. So if you're new to this channel, make sure you subscribe, like, and share the video with your colleagues that are going to find it helpful as well. Without wasting much of our time, let's move into what we have in this lesson: mathematical expectation. Mathematical expectation. So if x is a discrete random variable, that is, if x is a random variable that is discrete, the mathematical expectation when x is a discrete random variable, the mathematical expectation is given as E of x, that is the mathematical expectation. The expected value of x is given as what? The summation of x f of x. The summation of x multiplied by what? F of x. Summation of x multiplied by, please take note of this sign. X multiplied by summation x multiplied by f of x, where f of x is what? Is your probability function. Where f of x is your what? Is your probability function. Please take note, you can be asked to find the expected value of anything. It may not be x, it may be a function. You might be asked to calculate the expected value of the function. What we also need to do is to multiply that function with f of x before doing the summation. You can be asked to even find the expected value of a constant. You can be asked to find the expected value of 1. What do you need to do? Just multiply 1 by your f of x, then do the summation. You can be asked to find the expected value of 2. What do you need to do? Just multiply 2 by f of x. You can even be asked to find the expected value of what? Of s squared. Just multiply the f of x by s squared before doing what? The summation. So when x is a continuous random variable, the mathematical expectation or expected value, the expected value of x is given as E of x, which is equal to the integral. You know, I told us anytime we are dealing with probability density function, what we be anticipating is what is the integral, unlike probability function where you are having what summation. Integral from what? From minus infinity to infinity. Don't forget. Multiplied by that x. Integral of that x multiplied by f of x dx. And in this situation, your f of x is what? Your f of x is probability density function. Integrating from minus infinity to infinity. You'll be given that function and you'll be given what? Boundary conditions. You'll be given boundary conditions. Similarly here, you can be asked to find the expected value of anything. It it may not be x, it may be x squared, it may be 2, it may be 1, it may even be a function, another function on its own. It can be another function on its own. And I also want you to take note that you can be asked to calculate mean, variance, and standard deviation from expected value. From expected value. I want you to take note that when you have to calculate mean from expected value, your mean is the expected value of x. You don't need to stress yourself. Your mean is your what? Expected value of x. So mean is equal to expected value of x. But your variance sigma squared is equal to the expected value of x squared minus the square of expected value of x minus the square of expected value of x minus the square of expected value of x. Then your standard deviation sigma will be square root of what? Square root of variance. Square root of variance, which is equal to the square root. So anything you get in your variance, just take the square root, which will be the square root of what? Of x squared minus the expected value, square of expected value of x. Square of expected value of x. So we have been able to define our mathematical expectation. So without wasting much of our time, let's move into an example. Example 1. Example 1. The question says, find the expected value of random variable x having the probability distribution function f of x, which is equal to the modulus of x minus 2 over 7 for x equals 0, x equals minus 1, minus 1, 0, 1, and 3. Minus 1, 0, 1, and 3. Somebody might be wondering that why do I have minus here? Yeah, we can have minus. Because the rule or the condition for probability function is that f of x must not be negative, that is, must not be less than z. But x can be negative, x can be anything. It's just that it must be discrete, it must be well defined, it must not be in form of inequality. But your f of x must not be what? Your f of x must not be less than 0. That's even one of the reasons why the question is having modulus. You know, the function of modulus is to what? Is to eliminate anything negative. So that's the question we're given. That's the question we're given. So solution. Let's solve for that. So we have to find the expected value of what? Of x. So to determine the expected value of x, you know, what we'll be needing to do here, this one is probability function. We'll be needing to do what? A summation, expected value of x, which is equal to what? Summation of what? Of x, summation of x multiplied by what? F of x. So the first thing you need to do is to input your x into f of x one after the other. So why don't you just generate the table for that? That would be more easier. So let's generate the table for that. So let's say this is for x and this is for what? This is for f of x. This is for x, this is for f of x. We have minus 1, 0, 1, and we have 3. So when x is equal to minus 1, what you just need to do is to plug it into the formula minus 1 minus 2. that will give us what? That will give us minus 3 over 7. But the modulus here means that you don't need negative. So anywhere you find modulus, it means that you should what? You should eliminate negative. Automatically, that minus 3 over 7 will become what? Will become 3 over 7. 3 over 7. The next thing is to input your 0. 0 minus 2, that's minus 2 over 7. So f of x here is what? So we are going to be neglecting the minus. That will be what? 2 over 7. We also have 1 minus 2 over 7. That will be what? That will be minus 1 over 7. You neglect the minus. That will be what? That will be 1 over 7. Similarly for here, x, you have what? You have x minus 2 over 7. That will be what? That will be 3 minus 2, and that's 1 over 7 as well. 1 over 7. 1 over 7. So I've been able to determine all our f of x. All our f of x. Determine all our f of x. So the next thing is now determine our expected value of x. So expected value of x says we should multiply, we should sum x and we will sum the multiple of what? Of x and f of x. So we take that multiplication one after the other. For the first one, your x is what? Minus 1. X is minus 1, that will be minus 1 times, what's the corresponding f of x? 3 over 7 times 3 over 7 plus the next one 0. What's the corresponding f of x? 2 over 7 2 over 7 plus 1 times 1 over 7 plus 3 times 1 over 7. 1 over 7. So if we do this very well, if we add everything together, we should be having 1 over 7 as the answer. 1 over 7 as your expected value of x. 1 over 7 as the expected value of x. It's as simple as that. So let's move to the second example on probability function or mathematical expectation of probability function. Example 2. So this example says find the expectation of a discrete random variable x. We have been told that it is what is a discrete random variable, that's automatically probability function of a discrete random variable x whose probability function is given by f of x equals to 1 over 2 raised to power x for x equals to 1, 2, 3, dot. We have been told that these variables are discrete, but we are not given everything. We don't know where it stops. It's an infinite number. It's an infinite number, but it is discrete. That doesn't make it continuous. That is, since we are not having it in form of inequality, so we cannot say it is what? We cannot say it is continuous. So it is discrete. But we are going to be having our summation in form of what? In form of series. And the question has already stated that it is what? It is a discrete random variable. So we don't need to treat it as continuous. We are going to be treating it as what? As discrete. So this is f of x has been given as what? 1 over 2 raised to power x. So we are asked to find the expected value of x. We have to find the expected value of x. So that means the first value of x, we call that it is summation of x, f of x, summation of what? Summation of x, f of x. So let's write what we have. So we are going to generate table since we don't know where this one is ending. So let's just write it in form of an infinite series. So let's be having what? We'll be having 1, the first one is 1, when x is 1 multiplied by 1 over 2 raised to power 1 when x is 1 plus 2 into 1 over 2 raised to power 2 plus 3 plus 3 plus 2, and you can even write it up to 4. 1, 2, 3, 4, 5, 6. Well, to make it more easier and to make it makes more sense, we can write it up to 4. So we have 3 times 1 over 2 raised to power 3 plus 4 times 1 over 2 raised to power 4 plus dot. So that reproduce shows that it is what? It is an infinite series. So let's break this down. If you break this down, we should be having 1 over 2 plus here we are having 2 into 1 over 2 raised to power 2 is more of saying 1 squared over 2 squared, and that will give us 1 over 4 plus 2 into 1 over 4 plus, so you can do all these things in calculator, you don't need to share your brain. 3 into 1 over 8 plus 2 raised to power 3 is 8. 3 into 1 over 8 plus 4 into 1 over 16. 2 raised to power 4 is 16. But don't forget, it's an infinite series plus dot. Triple dots. So we are going to generate that. This is our expected value. So what do you need to do? In this situation, we need to sum everything together to get a single value, because this particular series, it has an ending point, but we just don't know that ending point. We don't know the ending point, but it has an ending point. So we need to generate the particular number. We can't leave it like this. We need to determine the exact expected value. So what we need to do, you can there's a way of manipulation or trick which we can use to get the exact expected value. So we can say let our expected value equals s. We can represent our expected value equals s. So we can say s equals to what? 1 over 2 plus 2 into 1 over 4 plus 3 into 1 over 8 plus 4 over 16 plus dot. So the next thing we can look for half of s. So half of s will become what? Half times 1 over 2 will give us what? 1 over 4. That's 1 over 2 times 1 over 2, and that's what? That's 1 over 2 times 2, and that's 1 over 4. This gives us 1 over 4 plus half of 2 over 4. Half of 2 over 4. Half of 2 over 4 will be giving us 1 over 4. 1 over 4 as well. We'll be having 1 over 4 or more. Let's say, in order not to manipulate or not to eliminate these two, let's deal with the one in the bracket. So 1 over 2 multiplied by 2 into 1 over 4, that will be giving us 2 into 1 over 2 times 1 over 4, and that will give us 2 into 1 over 8 plus 2 into 1 over 8 plus 3 into, so we don't want to touch the number outside, so we are having 1 over 2 times 1 over 8, and that will be giving us what? 1 over 16. 1 over 16 plus 4 into 1 over 2 times 1 over 16, that should be giving us 1 over 32. 1 over 32, 4 into 1 over 32 plus triple dot. So we have been able to determine s and we have been able to determine what? 1 over x. So the next thing we can decide to what? To subtract s, subtract 1 over s, 1 over 2s from what? From s. You know, when you subtract s, 1 over 2s from s, you're going to get s back. You're going to get 1 over 2s back. You're going to get 1 over 2s because 1 minus half will give you what? Will give you half. So here we have what? S minus, then from there you can cross multiply or make s of the formula to get your expected value. So it's just some sort of manipulation. There's no a big deal there. Just to, and to make it easier, it's something you can even use a calculator with. You can use the series, the summation symbol in your calculator, and you can just do trial and error to get the points where you sum it up to. You know, your summation symbol will ask you where to start from and where to end. So we're going to be starting from 1, then you can firstly end at 10, check what you're going to be given, then you can check it up to maybe 20 or 30, then you compare till you get a whole number. So here we have s minus 1 over 2s. S minus 1 over 2s. So let's subtract these values from these values. So what we will be having, this one will give us what? This will give us 1 over 2 plus 1 over 4 plus 1 over 8. So we can do that with the calculator, plus 1 over 16 plus dot dot dot. You can check that and check that with the calculator. So we've been able to determine s minus 1 over 2s, we've been able to determine s minus 1 over 2s, which will definitely be what? Which will definitely be 1 over 2s, because 1 minus half will give you what? Half. 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16 plus dot dot dot. So if you add this value, you know, it has been reduced up to this. This has been reduced to this. So if you add, you can easily add this together. If you add this together, even without doing it up to it, if you add this together, your value will be moving close to what? Your value will be moving very close to 1. Very, very close to 1. 0.999 something. So your value will be moving very close to 1. Then you should know that if you add it up to the right number of series, then the exact addition will be what? Will be 1. So automatically half times s will be equal to what? Will be equal to 1. Then making s is already the formula, s equals to what? Equals to 2. Automatically the expected value of x is equals to what? Is equals to 2. The expected value of x is equals to what? Is equals to 2. And that's the answer to that. So before moving further, before moving to the next aspect, which is expected value under probability density function, I would like to give us some theorems on expectation. The reason why I want to give us this theorem is to reduce our aspects. You know, there are some questions that will be given instead of going through a very long process. Then if you know this theorem, it's going to make the solution easier for you. So the first theorem of expectation says if C is a constant, then the expected value of C times x will be equal to C times the expected value of x. So that's what the first theorem says. That is, anytime you are having a constant in your expected value, so just bring out the constant. You don't need to be taking the constant all along with the random variable which you want to work. Even if it's not random variable, if it's a function, that is, you want to find the expected value of a function, and you can see that a constant is common, just bring out the constant. So you don't need to be taking the constant along with the variable. So that's the first theorem. So the second theorem says if x and y are any random variables, then the expected value of x plus y, the expected value of x plus y should be equal to the expected value of x plus the expected value of y plus the expected value of y. So at some point you may be having problems involving summation, that is the sum of two values, two variables. So you can just separate them and look for the expected value of one plus the expected value of the other and add the two together to get the expected value of the total. So that's another theorem. And the third theorem is a multiplication. It says if x and y are independent random variable, then the expected value of x multiplied by y is equal to the expected value of x multiplied by the expected value of y multiplied by the expected value of y. So those are the three popular theorems of expectation. So once you know these three theorems, it will save you a lot of stress. It will save you from a lot of stress when you are solving problems on that. So without wasting much of our time, let's move into the mathematical expectation under probability density function. Example, here we move into the expected value under probability density function. So the example I'm having here says if the density function of that we stated density function, if the density function of the random variable x is given by f of x equals to 1 over 2x 0 otherwise, and this is 0 less than x less than 2. Find the expected value. Find the expected value of x. Find the expected value of x. Solution. Here it has been stated that f of x is what? Is a density function. And I need to know the expected value, ways of calculating the expected value of density function. Expected value of density function is to what? Is to integrate from minus infinity to infinity of x times that f of x dx. X times f of x dx. X times f of x dx. So here we have what? We have the integral from 0 otherwise. That will be minus infinity to 0. Minus infinity to 0 dx, 0 dx. But don't forget, we are not only having the function, we are having x multiplied by the function. So this will definitely be what? X multiplied by 0, x multiplied by 0 dx, plus this is ending at 0. So this is automatically starting from what? From 0. 0 to where? To 2. Don't forget, 0 less than x less than 2. So that's 0 to 2. Now integral of what? X, because we are looking for the expected value of x. X multiplied by f of x, which is what? Which is 1 over 2x. Which is 1 over 2x. 1 over 2x. dx. Everything here will automatically become 0. That's 0 plus. Then if we integrate this, x times 1 over 2x will definitely be what? X squared over 2. So if we integrate x squared over 2, should be able to integrate by now. We've been integrating in the previous lesson. So integration of x squared over 2 will definitely give us what? X cubed over what? Over 3 times 6, and that will be 3 times 2, and that will be 6. Because we already have 2 before, and if you wish, you can bring out 1 over 2 as constant. So that was x cubed over 6 from where? From 0 to 2. From 0 to 2. From 0 to 2. So automatically our expected value will what? In introducing our boundary condition, we have what? 2 cubed over 6 minus 0 cubed over what? Over 0. So here we have what? 8 over 6. 8 over 6. 8 over 6, which can be reduced to what? Which can be reduced to 4 over 3. Which can be reduced to what? Which can be reduced to 4 over 3. And that's the answer to that. That's the answer to that. Let's move to the next example. And this one is also under probability density function. So this one says a continuous random variable x has the probability density given by f of x equals to 2 exponential minus 2x 0. Here we have what? We have x greater than 0. Here we have what? S greater than or equals to 0. And this is more otherwise. Solution. We have to find what? We have to find two things. Find A, the expected value of x, B, the expected value of s squared. The expected value of s. And even from these two information, if you have to find the variance and standard deviation, I've given us the formula in the beginning of the lesson. So it is definitely expected value of s squared minus the square of expected value of x. That will be the variance, and standard deviation will be the square root of that value. So the first thing, expected value of x, remember integral from minus infinity to infinity of x times what? Times f of x. Of x times f of x dx. Here we have what? Integral from, let's say, minus infinity to 0. Minus infinity to 0. I have it from minus infinity to 0 of 0 times x dx plus the integral from where? From 0 to infinity. Because this one we don't know where it stops. X is there and 0. We don't know if it is up to 100 or whatever. So we have it up to infinity. Then in that situation, we have to check what is 2 exponential minus x. But don't forget that we are going to multiply by x first. So you are finally having 2x exponential minus 2x dx. 2x exponential minus 2x dx. So this automatically becomes what? 0. So you'll be left with this 0 to infinity 2x exponential minus 2x dx. 2x exponential minus 2x dx. So you can bring out 2. And bring out 2. 2 is the constant. 0 to infinity x exponential minus 2x dx. So by solving this, we are going to be solving this with integration by parts. We are going to be using integration by parts to solve this particular integration. So since we're having two functions multiplying each other, and that's why we're taking a long period of time to do, and to prevent this video from being so lengthy. So you can I'll just be writing out the solution so you can visit any engineering textbook to understand how to integrate by parts. So I'll just be writing out the solution to that, the result to that. So the expected value of x will finally become what? Finally become 2 into x into exponential minus 2x over minus 2 minus 1 into exponential minus 2x over 4. From where? From 0 to infinity. From 0 to infinity. From 0 to infinity. So let's introduce our boundary condition. Introducing our boundary condition. So like I've said earlier, I just decided to write out the results. If you want to integrate that, you are going to be using integration by parts. Please kindly visit any engineering textbook to understand how to integrate by parts. We are decided to be solving that with integration by parts, then the lesson will take a very long period of time, because we are going to be integrating by parts again when we want to do for the expected value of what? Of x squared. So here we have what? 2 into, we want to introduce our boundary condition. We have what? Infinity, or let's say infinity into exponential minus 2 into infinity over minus 2 minus 1 into exponential minus 2 into infinity over 4 close the brackets, minus, don't forget, we introduce that of 0 as well. So we have 0 into exponential minus 2 times 0 over minus 2 minus 1 into exponential minus 2 into 0 over what? Over 4. Close the bracket, then close the outer bracket. But don't forget, minus 2 times infinity, you definitely give me minus infinity. And exponential minus infinity, as we already know, is what? Is 0. So automatically everything here becomes 0, and everything here also becomes 0, because this is also having exponential minus infinity. So that also gives us what? That also gives us 0. So we have what? By that 2 into minus, this will also become 1. This will become minus, this becomes 0 rather. We have 0 here. 0 is outside. So automatically everything here becomes 0. But we are left with this exponential minus 2 times 0. That will give us exponential 0. And anything raised to power 0 is what? Is 1. But we are having minus here. We are left with what? Minus 1 over 4. Don't forget, there is still another minus here as well. Minus, and that's minus times that minus 1 over 4 becomes what? becomes 1 over 4. 1, so everything here is reduced to what? 1 over 4. Then if you multiply this 2 by that 1 over 4, you left with what? You left with 1 over 2. So the final answer to this is 1 over 2. That's the expected value of x. So to determine the expected value of x squared, in a similar way, or integrate from minus infinity to infinity of x squared f of x dx, x squared f of x dx, then you know we'll be integrating from minus infinity to 0 or what? Of x squared times 0, because f of x is 0 for the other condition from minus infinity to infinity dx, plus the integral of what? 0 to infinity, because we are having greater than 0 and you know we don't know up to which point. So here we have what? We have x squared times f of x in that boundary is what? Is 2 exponential minus 2x, 2 exponential minus 2x dx, 2 exponential minus 2x dx. So automatically, you know, this becomes 0, this becomes 0, and this, we are left with the integral of this, which we can bring out 2 as a constant. We have 2 x squared exponential minus 2x from 0 to where? To infinity dx. Similarly, you have to solve this by what? By integration by parts to determine the value. I won't be doing that in this lesson, so I will just be writing out the result. So you can go and try this by integration by parts to get the answer to that. So if you do this very well by integration by parts, you get in x squared into exponential minus 2x over minus 2 minus 2x into exponential minus 2x over 4 plus 2 into exponential minus 2x over minus 8 over minus 8. From where? From 0 to infinity. From 0 to infinity. From 0 to infinity. So we can now introduce our boundary condition. You can introduce our boundary condition. By introducing our boundary condition, here we have 2. 2 is a constant on its own. So let's bring in another bracket. Here we have what? We have x squared, and the first one is what? Is infinity. So let's put it directly. We have infinity squared into exponential minus 2 into infinity over minus 2 over minus 2 over minus 2 minus 2 into infinity into exponential minus 2 into infinity over what? Over 4 plus 2 into exponential minus 2 into infinity over minus 8 over minus 8. Then we close the bracket. To that. Minus, when x is what? Is 0. So that would be 0 squared into exponential minus 2 times 0 over minus 2 minus 2 into 0 into exponential minus 2 into 0 over 4, close the bracket, plus 2 into exponential minus 2 into 0 over minus 8, close the bracket. Then we finally close closing this bracket, then finally closing the entire bracket with a what? With a square bracket. So let's simplify that. We have 2 outside here. So automatically we are having exponential minus 2 in times infinity, that will give us minus infinity, and anything raised to power minus infinity will give us what? 0. Automatically this becomes 0. Similarly, this becomes 0. Here we are also having exponential minus infinity, which will also give us what? 0. And here we are having what? We are having 0 at the front of this, and 0 multiplied by anything becomes 0. Likewise this becomes 0, and this we are having exponential minus 2 times 0, and anything times 0 is still 0, and anything raised to power 0 will give us 1. So automatically this becomes what? This becomes 2 times 1 over minus 8, and that becomes what? Minus 2 over 8. But don't forget we are having minus here, and that automatically becomes what? That automatically becomes plus 2 over 8. We have 2 over 8 here, 2 over 8 here, and 2 here 1. This gives us what? This was 4. That automatically what? 2 into 1 over 4. Here we have 2 as well. 2 times 1 over 4. 2 here 1, 2 here 2. We are definitely left with what? 1 over 2. So the expected value of x is 1 over 2. The expected value of x squared also gives us 1 over 2. So let's say we are now asked to find the variance. Though we are not asked in this question, but let's assume we are asked, so that we can understand the concept better. So we are asked to calculate the variance, which is sigma squared, and which is the expected value of x squared minus the square of the expected value of x minus the square of the expected value of x. The expected value of x squared is 1 over 2. 1 over 2 minus the square of the expected value of x, which is what? Which is 1 over 2 squared, and this automatically gives us 1 over 2 minus 1 over 4. Take the LCM of this, you have what? You have 4. 2 here, 2, you have 2 minus 4 here, we have 2 minus 1. That's automatically 1 over 4. 1 over 4. So the variance is what? Is 1 over 4. What about the standard deviation? So you have to calculate the standard deviation as well. You have to calculate the standard deviation sigma. You're going to be having the square root of what? Of 1 over 4, which will give you what? Which will give you 1 over 2. 1 over 2. So the standard deviation is 1 over 2. The square value of x is 1 over 2. The square value of x is 1 over 2. Why the variance is what? Is 1 over 4. Why the variance is 1 over 4. Just an analogy actually. So that's a very good example on the expected value for probability density function. Probability density function. So we also be talking about another example, which is going to be our last example in this lesson. So this involves finding the expected value, mathematical expectation of another function. So this question says if x has the probability density function, if x has the probability density function of exponential minus x 0, x greater than 0, here we have s squared. So the expected value, it says find the expected value of random variable, find the expected value of random variable g of x, which is equal to what? Exponential 3x over 4. Exponential 3x over 4. Solution. So we have to find the expected value of that random variable exponential 3x over 4. Exponential 3x over 4. So the expected value of g of x, the expected value of g of x is simply g of x, the integral of g of x multiplied by f of x, because this is definitely a probability density function. So we have what? The integral from minus infinity to infinity of what? Of g of x times what? Times f of x dx. G of anything you have here, just multiply it by f of x. So here we have what? The integral from minus infinity to what? To 0, because we are having s squared. Minus infinity to 0, multiply by what? Multiply by 0 times, because f of x is 0 times g of x. What is g of x? Exponential 3x over 4. Exponential 3x over 4 dx plus we ended at 0 here, so we will be starting from 0 to where? To infinity, because it says x greater than 0. We don't know up to which point. We don't know if it's up to 100 or whatever. So here we have exponential 3x over what? Over 4. Exponential 3x over 4 times f of x, and f of x here is what? Minus exponential minus x dx. Exponential minus x dx. So this automatically becomes 0. This will become 0 because we have 0 times 0 is multiplying that function there. So it automatically becomes 0. So we want to integrate that, but before we integrate, we can simplify that. So integral from 0 to infinity. So in simplifying exponential, you can apply your indices. Exponential is common, so you can add up the numerator. So you can add up the numerator. So adding up 3x over 4 and minus x, 3x over 4 minus x. So you have what? 4. You have 4 as your SCM. 4 and 4, 1. Here you have 3x. 1 and 4 times this, you have minus 4x. So automatically you are left with what? Minus x over 4. Minus x over 4. Minus x over 4. So that gives you exponential minus x over 4. So we are left with what? We are left with integral of exponential minus x over 4. Exponential minus x over 4 dx. So now let's integrate. I already taught us in one of our lessons how to integrate exponential. Anything exponential, how do you integrate it? So there's a short trick for that. Just differentiate the index, that is the exponent. Just differentiate it. If you differentiate minus x over 4, what will you be having? If you differentiate minus x over 4, you'll be having minus 1 over 4. So minus 1 over 4, just use minus 1 over 4. Just need to divide exponential minus 4 over minus x over 4. So we are having what? Exponential minus x over 4 divided by what? Divided by minus 1 over 4. From where? From 0 to infinity. But we can further simplify this. So if you want to bring minus 1 over 4 up here, it becomes multiplication. That will be divided by minus 1 over 4, and if that becomes multiplication, it becomes what? Times 4 over minus 1, and that's automatically minus 4. So automatically this becomes what? Minus 4 into exponential minus x over 4 from where? From 0 to infinity. From 0 to infinity. So let's say we use our boundary condition. You have what? You have minus 4 into exponential minus infinity over 4 minus exponential 0, because you have exponential minus 0, which is also 0, over 4 and here we know that minus infinity over 4 will become minus infinity, and exponential minus infinity will give us what? Will give us 0. Automatically everything there is 0. Minus 4 into 0 minus 0 over 4 will become what? Will become 0. Minus 0 is still 0, and exponential 0, anything raised to power 0 will give us what? Will give us 1. So here we have what? Minus 1. So automatically we are left with minus 1 here. Minus 1 times minus 4, automatically we are left with what? We are left with 4. We are left with 4. And that's the answer to that. So that example will bring us to the end of this particular lesson. So if you are new to this channel, kindly make sure you subscribe, you like, and share the video with your colleagues who are also going to find it helpful. Tutor Bosun is here. Thank you.